Okay, good evening everyone. My name is Prasanna Menta. I am teaching Data 620. There are 4 sections and I am managing one of the sections. And I'm here to present you the live webcast for SQL, understanding the basics of SQL and ER diagram. Time permitting, we will go into normalization concepts, which is very, very critical. Understanding is required in order to be very effective in creating ETL diagrams for data mining, those kind of activities. So a good overview of the course. Initially, we start with our SQL, use of SQL until week 6, week 7. Then we go into Tableau. From Tableau, we start using Python. That is the nature of this course. You will be having extensive assignments where we will take you from one tool to other. Activities are very clearly illustrated. All the instructions are outlined in the assignment document. As always, if you have any questions, please do not hesitate to reach out to the faculty assistant or your respective faculty of your course. So having said that, I would like to share my screen so you could see a presentation. Then I will also hand over to Deepa, who will illustrate the tool. Now, is this clear or you want me to go as a slide show? Are you able to see the slides? Deepa?
Yeah, I'm able to see the slides.
Okay.
I'm not sure if all of you want it as a presentation, or is this format okay for you guys?
The reason is I want to use some notepad on a simultaneous basis. That's the reason I'm not making it a slideshow. Okay. Now, let's start the SQL basics. For this course, we have students from various areas. Some students are coming with a strong background of programming. Some are from analytical backgrounds. Some are from the business areas. So we want to take it one step at a time, start from the basics and go to the advanced in order to make use of the tool. So having said that, let's look at the SQL basics. The basics, you need to understand what are the various data types. I'm not explaining all the data types in the database. I'm just giving the key data variables that will be useful for this course. Some of the concepts which I am covering, the entire presentation, I took about the important aspects which will help you with this program or with this course. Some of the concepts take about 3 to 4 hours in my regular Data 651 class. So here I am taking what are important aspects, what are key to you for your understanding, just to get a feel of what and how we do things. So in order for a database or in order for data to exist in a database, we create something called as tables. If you want to create tables, the tables are nothing but rows and columns. And the columns are called column headers, which are attributes for the columns. Each of the column attributes can be varied types. The types can be character, varchar, or date. These are 3 critical things I just wanted to discuss. There are other things like if you want to do date timestamp, then you can go integers, then sign, various other things are there. We will not go into those things. So if you want to insert some kind of a, I forgot about numeric. So if you are doing number types, you will be creating the columns as numeric. If you want to store elements, some like a characters, which is alpha, A, B, C, D and all, you will be using character. If you want to use alphanumeric, normally they go with a varchar. If you want to store date in the columns, you will be defining that column as a date variable. So these are the 4 data types which may be very significant and useful to you in the program. So now, before going into creating a table or creating columns, we need to understand some of the important things which come with the tables. Some people call records, some people call entities, but everything has the same meaning. So why do we need tables, and why would we need they to be related, and how do we maintain consistency of data within the tables? So when you look into these constraints, there are 2 types of constraints which we need to understand. Based upon this constraint, we create some structures called as primary and foreign key or referential keys. For example, if you are creating a table and the table has a student information, let's say you are creating a table with 2 simple columns. The columns can be student ID and name. These are the 2 columns I am creating. Let it be numeric, and this can be, let's say character for the time being. So if you are creating the table with 2 columns to store student ID and name, and if you want to maintain uniqueness of the table, in order to maintain integrity of the data, you need to make sure the entities are traceable and you do not enter duplicate redundant values. What I mean to say is 001 is the student ID and I'm telling John, and 002 should be a different variable, something like that. So you should not be able to insert 003 or 002 as that is a problem. So if you look into it, the data is corrupted. So 002 is assigned to Abdul, 002 is assigned to Kim. So this is a wrong way of using the tables. So this is called as the integrity constraints, and it is called as the entity integrity. What is entity integrity? Entity integrity ensures the integrity of the table is protected. For example, 001 is John and 002 will become Mary. 003 will become something like that. So in order to enforce this concept, we use something called as primary keys. We have to look at the columns. We have to identify which column is a candidate for a primary key and assign that column as a primary key. When you assign the column as a primary key, it enforces the constraint and it will not allow you the duplication value. So in this table, 001 is the student ID and John is the name. Now, we have to see which can maintain the uniqueness of the table. So normally ID can maintain the uniqueness. So ID becomes the primary key in this example. Now what is referential integrity? So we have a table called student. We also have a table called course. So course has a course ID and description. Now imagine these 2 tables are connected. Let's say a student can register for 1 or more courses, and a course can be taken by 0 or more students is the connection between these 2 tables. Now, when a student registers for a course, they should register for the course which is really available and which is a valid course. That is That type of enforcing is called as referential integrity. Referential integrity means if you're connecting two tables, the tables will be connected by key values. When you insert a data, it goes and checks if the data is valid. If the data is invalid, it will not allow you to insert the data into the tables. That is called as referential integrity. So entity integrity is enforced by primary key. Okay, so you should understand this. Then referential integrity is enforced by foreign key. So remember these two concepts. So this is what I have explained here. Now, apart from these two, there are other values which are of significantly important. But for this course, this program, for this data 620, if you understand primary and foreign key, you will be able to move on. So for some cases, if you want to really understand, you can understand what is super key. Super key means columns with a unique values. Candidate keys means it's a minimal super key. It's called as a candidate key. Null value means you will assign null values, meaning the values will be blank for certain columns in certain table for certain reasons. That is called as null value. Primary key, I explained you, it is required for entity integrity constraints. Foreign key is required for maintaining referential integrity concepts. So these are called as the key definitions. Now, having understood columns, having understood what is the tables, having understood what are the constraints or integrity and referential integrity concepts, now let's look at different SQL types which are significantly important for us to understand. The first one is called as DDL. DDL means data definition language. What is data definition language? When you are creating a table, when you are creating an index, when you are creating a view, when you are creating some object in the database, you use a language called as data definition language. So what is the example here? Now I have defined the student, and then there is a syntax, what we call as create table, table name. Then we put our column attributes, then put a semicolon and run the statement in the SQL tool. That creates the table called student in the database. That type of a SQL syntax is called as data definition language. Then the second type of language is data manipulation language. Data manipulation language is nothing. It is when you want to update, when you want to delete, and when you want to make changes. All the changes becomes update statements. Okay, so those are issued by data manipulation language. What is so? So this is an example of a delete statement. You are deleting a row for a student ID of 1. That's called as the data manipulation language. Where it is concerned of DCL, it's a data control language. This is mainly an administration language. Say if you want to assign privileges, revoke privileges, it is normally done at the database administrator level. That's called as data control language. These are the three broad categories. Recently, they broke DCL into further 2 categories. Let's not worry, but let's understand what is a DDL, what is a DML, and what is DCL. Now, any questions so far here? I'm going to go to wholly a different chapter. Okay. The silence, I'm going to understand there is no questions from your side. Okay. Now, let's look at ERD basics. I think somebody has to mute their phone, the microphones. Please mute your microphones. Okay. Now, what is ERD? Entity relationship diagram is called as ER diagram. I'm still getting a resound. Can you please mute your phones, please? Okay. This is clear. Now, no resounding is not there. Okay. Now, when you look at ERD basics, so what is an entity relationship diagram? For example, you are a technical manager, or you're a technical developer, or you're a technical lead. Assume Deepa is the business analyst or the business subject matter expert. You want to create certain objects or certain applications for the organization. So normally what happens is Deepa writes a functional requirement document. From the functional requirement document, it comes to the technical people who review the functional diagram or the functional requirement document and create a technical specifications. When you do the technical specification, so what happens is they create something called as entity relationship diagram. So for the requirements, they create some kind of a diagram and explains to the business analyst, hey, this is how I understand your requirements. Do you think this makes sense? So that is how you represent, and that is how you record, that is how you document, how you create your application in the database. So doing that, there are various tools are available. For the course, we can use a simple tool called ER Assistant. ER Assistant is a student version of the tool, which has been given to the use by a prominent author of a book, which is Manino. He has developed the tool and he has given for us to use as needed. It is a free downloadable tool, and it's a very simple and very easy and less complication, straightforward tool. So if in order to use the tool, we need to understand what we are trying to do so that the tool can be effectively used. So let's create a simple scenario. Deepa is the business analyst. Okay. Okay, I simply gave some scenario for the ease of understanding of the concept. Now, Deepa is creating a business requirement document or functional document and providing it to the technical IT department. Hey, I want to create a university database which can enroll students and register them for courses. Now, when you look at this functional requirement documents, all the nouns will become entities. Okay, all the verbs become relationships. So keep these simple things in your mind. Now, looking into this, we understand there are two nouns called student and course. So these two becomes automatically tables. Tables are entities. Okay. Now, what are attributes? Attributes are columns. So for a student table, you have attribute called student ID and name. Okay. Attributes are columns. For course, we have course ID and description. So this become attributes. Now, when you call relationships, relationships are nothing but rules to be enforced on the tables. Each student, so these two becomes rules. Okay, these becomes relationships. So we copy it here. So rule 1 is each student can, okay. Then rule 2 is each course can have 0 or more students. So this is the how the technical people will dissect the functional requirement document. Having dissected this, we have to translate into an entity relationship diagram. Once the entity relationship diagram is established, reviewed, approved, then we create that diagram and convert into scripts to create them objects in the database. So the first step is we need to understand the basics. When you look at the basics, we need to understand what is an entity. Entity is nothing. It can be called as a table, a record, whatever. Everybody calls in a different meaning. But for the simplicity, let's call tables as entities. Entities store rows and columns. Rows are the details of the data, where columns are the header. The header row is called columns. Now, relationships. The relationship exists between two tables. The connection between two tables are called as relationships. With the use of relationship, we would be enforcing the rules or business rules on those. Then, what are columns? I explained you columns or attributes are the same. So, when you create an entity, you create column or attributes by defining in a suitable way. For example, if you want to store numbers, you will store purely a numeric column. If you want to store alphanumeric, you go with a varchar. If you are pretty sure 100% you only want to store alphabetic, then you will go with a character column. Then cardinality of the relationships. When you create the relationship, which we will show you, then you enforce a cardinality of relationship. A student can be 0 or more courses, and this 0 or more courses becomes a relationship by enforcing a cardinality, which we will illustrate, show you in the diagram, and you will be able to understand. For the time being, keep the cardinality open-minded. Okay. Then let's go and understand what is relationships. When you talk about entity relationship diagram, there are 3 types of relationships: one-to-one, one-to-many, and many-to-many. For example, what is one-to-one? A student can enroll into one course. A course can be enrolled by one student. This is called as one-to-one relationship. One-to-many relationship. A student can enroll into one or more courses. A course can have one or more students. Many-to-many, many courses can have many students can take many courses. This is a straight relationship without any cardinality. When I show you the ER diagram, how we create ER diagram, I'll show you the cardinality, I'll show you how it is enforced. So you will be able to understand the meaning of the cardinality on the relationships. So let's summarize what I have covered so far. So we started with an understanding that we need to be able to define SQL, we need to define an ER diagram. That was the basic fundamental understanding for us. So we do not know what is an SQL. So we started with understanding the different columns, attributes, then how they are created, what type of column attributes they are. Then we understood the constraints, what is entity and referential integrity constraints, why do we need constraints, how the constraints are enforced and created. So constraint is created by primary key. Referential entity is crossed by foreign key. From there, we understood what are the different types of SQL. Data definition language, data manipulation language, and data control language. So, having said that, we moved on to entity relationship diagram and its basics. Why do we need an ER diagram? Once business requirement document or functional requirement document is received from the business analyst to the technical point of contact, the technical person reviews that document and converts into a technical specification. Technical specification will include an entity relationship diagram. The entity relationship diagram is nothing but converting what is needed into a diagrammatic format for review and approval. Once the diagram is approved, we create the objects into the database by use of respective SQL. So in order to understand entity relationship diagram, we have to understand what is entities. Entities are nothing but tables. Then we also need to understand what is relationship. Relationship are connections between two tables, and to enforce the business rules, we connect the two tables and connect by relationship and enforce certain cardinalities. Then how many types of relationships are there? There are three types of relationships: one-to-one, one-to-many, and many-to-many. Please note, for all your entity relationship diagram, please do not use many-to-many relationships. Many-to-many, if you create, it will cause circular type of relationships in your entity relationship diagram. So when you have a many-to-many scenario, you have to break into two one-to-many relationships. This is a basic system rule. You need to remember, it is a problem with the ER diagram. When you convert the ER diagram into SQL scripts, you will run into issues. So you need to understand the concept of many-to-many. When the concept of many-to-many comes into play, you have to convert that many-to-many into two relationships of one-to-many. It's, in other words, if we have two tables, student and course, and they're having a many-to-many relationship, you have to create an intermediate table and connect so that many-to-many becomes two one-to-many type of relationships. That is what you need to understand. So, any questions so far? Is it clear? Am I making it simple? Am I making it easy to understand?
Yeah, it's going good so far.
Okay. Please, you need to speak up. If I'm going fast, I can slow down. If you're not clear on the concept, I'm touching what is very important for the course. I am not teaching a relational database course. I took the various concepts. These concepts, whatever I covered so far, it is 9 hours of lecture. I just took the basic important fundamentals and I'm delivering it to you. That's all. Please, if you focus on this, you will be able to do your assignments. Then if you want to learn more, please use, there are ton of online materials you can read, and if you have questions, always reach out to your faculty, reach out to your faculty assistants. They are here to help you. Okay? Deepa, you want to show your assistant or you want me to kick off so you'll take over? Yeah, however you want.
I can start. I can
Okay.
share screen.
So now I want to give it to Deepa. So she will show you the ER assistant tool. So first, Deepa, can you start from going from Aeronomy website?
Mm-hmm. Sure.
Okay. So that they know how to. I just want to make sure students know how to get to that. So she's using the virtual desktop. So you have everything installed on the virtual desktop. You don't need to install anything. You don't need to even install Tableau. It's already there. You can do your homework and you can move on. It's very easy. So she went onto the website, vda.aeronomy.net, and she's clicking on the fall data icon, and she will take you from that. Take over, Deepa, from there.
Okay. Hey guys, I hope you can all see my screen. So this is the virtual desktop that we've been talking about the last week, and I hope you all have access to this virtual desktop. So once you come in here, everything you need, all software you need for this course is already installed here. In here on the desktop, you'll see an icon for ER Assistant, and just double click on the icon and that should bring up the ER Assistant. This is the tool, this is the free tool that we were just talking about that can be used to draw ER diagrams. So basic look and feel is kind of similar to any Windows application. You have all the menu-based tools out here. If you just hover over each of these options here, it'll give you more details about what each of these icons stand for. So just now we just heard about the entity relationship diagrams and how there's three important concepts. There's an entity, there's a relationship, and then there's attributes to an entity. So there's a table, there's a column, and then each two tables are related to each other via a relationship. So using the same example that we just talked about, so how do you build an ER diagram that depicts a university database that shows a connection between student and course tables? So like we just talked about, each noun becomes an entity or a table. So in order to create a table, first step you would do is just click on this entity icon here, and this will bring up a panel, and you can select new option, enter the name of your entity. At this point, you can either enter all your entity names if you know all the entities that you're going to build, or you can just elaborate on this one entity. So I'll start with this. I know I need a student entity, and then I know I need a course entity. So I'll first name my two tables. So now you can stop at this point and hit close, and what that would have done is created two tables for you. So now you have the shell. The next task is to define the student. So we already know that our student table has one primary key attribute, which would be the student ID. So you can click on this. Let me go slowly here. You can click on the attributes option here and select new, and then define a new attribute. So let's say student ID is one of your attributes or one of your columns that you want to define, and you know that student ID is a primary key, so you'll check this option, and then you can define the data type. You already learned about the data types just now, and then if you already know the other attributes, you can start defining them here. So let's say I want to define a first name, and then I want to define a last name for a student. So this is in a very basic form. A student table can exist with just these three attributes. So now you can close it out of here, close it out of here. Now you can look at your student table. Now your student table has a primary key called student ID, first name and last name is defined. Similarly, you can do the same thing to the course table. Select course, and then select attributes, and then you can add a new entity called course ID, which again is going to be the primary key for this table. And then you can add course name, and so on. So for simplicity, I'll just stick with two attributes. So there you go. Now you have these two tables, student and course. And so if you remember our functional requirements, we said each student can be enrolled in 0 or more courses, and each course can have 0 or more students. So we need to define that definition, or we need to define that relationship between these two tables. So how would you do that? To do that, there is this REL, or relationships type option here that you would click on, and you get to name your relationship. So if you remember what was just discussed, we said every relationship is a verb. So you can name your relationship using a verb. So I'm saying a student takes courses. So I'm calling that would be the verb I'm using. So, and then the next thing is the cardinalities. We talked about cardinalities, and we talked about how tables can be related to each other using one-to-one, one-to-many, or many-to-many relationships. So in here is where you will get to define the cardinalities. For the sake of simplicity, just for this demo, I'm going to keep it simple. I'm going to say that, let's say if students can take more than one course and each course can have more than one student, how would we draw this diagram? So to define the cardinalities, the first thing you would do is you would first bring the two tables that are involved in the relationship. So we have student and course, which are part of the relationship. And now we're saying every student can be optionally involved in many courses, and each course can have zero or many students. So if I do this, let's see what it turns out. This is how it looks. So if you read this relationship aloud from one direction, so a student takes zero or many courses, and that's the crow's foot notation you're seeing, where you see three. If it's a strictly one relationship, one to many, you'll see one side will have a strict solid line. Because this is many, you'll have this crow's foot notation that simply signifies a student can take zero or many courses, and a course in turn can have zero or many students. So this is the simplest depiction of drawing an ERD, and you'll get to draw ERDs probably from this week and onwards. You'll get a lot of practice drawing ER diagrams. Let me stop here. Let me see if you have any questions about what we just did.
Deepa, show them the how to enter values to the attributes also.
Okay.
So if you entered the attributes very plain, you can show them if they want to give real values to the attributes.
Okay. So you mean as in a script?
No, select the first name.
Uh-huh.
So what Deepa showed you, she showed first name as a varchar. So she didn't put a value, how much length you want. So you can put a value there. If you want the field value to be 30, 35, 32, whatever you want, you can add the length there. That's what I wanted to illustrate. Yeah. That's all.
So what this does, it fixes the column length. So you're saying your first name can never be more than 32 characters long. And usually it's 125, but I just made it 32. So similarly, you can pick other fields and define the column length. See, so in these cases, I skipped defining a data type, but if I do define a data type, I get to pick the column length. Okay.
Any questions so far?
Hi, this is Mercera. So my question is just wanted to reiterate that I'm reading this right. So it sounds like you're reading from left to right across the diagram. As Deepa was saying, student can take, what is it?
Zero or many courses.
Right. A student can take zero or many courses.
But you can read from right to left also.
Oh, okay. So it's not just one direction. Okay.
And you always want to read your relationships aloud so they make sense. Sometimes you would have refined and then you could flip-flop. So it helps if you read your relationships aloud. Then if it doesn't make sense, you can fix it.
Okay, great. That's a good tip. I thought it was just, sort of one direction. I didn't realize that you could look at it from many different sides there. Okay,
no,
that's pretty neat.
You should always look from both sides.
Okay. That's pretty neat. Thank you.
Okay.
So let's go with the other relationships types, Deepa.
Okay. So we just did a simple one where we did zero to many, right? So let's say now I want to mandate that a student should take at least one course for him to become a student. So if I change that a little bit here, Let's see.
Please watch what happens to the relationship notation. Okay? Please.
All right, so all I did was change this radio button option to 1 here, and let me close it out and see what happens. So now if you read this relationship, it says a student can take 0 or 1 course. So you see how the crow's foot is gone. Now we have the mandatory 1 line here saying at least 1 course. A student should take at least 1 course. And I want to make it not optional but mandatory, because for anybody to be a student, you have to be in at least 1 course. So now you're saying a student should be enrolled in at least 1 course mandatory, and each course can have 0 or many students. So now this is a one-to-many relationship.
And the enforcement, like the mandatory and optional, are called as cardinality on the relationship. That is what I said. If I explain you theoretically, it will be confusing. Please watch out, and we'll explain in the ER diagram. That's why I kept it very simple. Okay?
Okay, and sometimes, guys, this is just an experience as a student myself. Sometimes I flip-flop while you're first creating these diagrams. You tend to flip-flop these. So that's why I said it's always helpful to read what you did. So now if you look at this, what you're saying is a student can take 0 or many courses, but a course should have at least 1 student. So reading aloud or saying this aloud will help you validate your functional requirements versus what your diagram is actually doing. So it's always a good habit to keep your functional requirements handy when you create these ER diagrams. All right, let's see. Are there any other questions?
One-to-one.
Okay. The next thing is one-to-one, where you are saying every student should take at least 1 course, and each course should have at least 1 student. So you're just saying one mandatory on each end. So if you read this aloud, student takes 1 course and course takes at least 1 student. And there's also this handy thing that checks the correctness of your diagram. So you can, after you're done, you can just check your diagram to see if there's any completeness or correctness error. And you don't have to get too hung up if you get a lot of errors, but this will at least pinpoint mistakes with your diagram if there are any.
Any questions on the ER diagrams? Okay. Deepa, do you want to show them the SQL or anything else you want to cover in the ER?
This is all I had in mind, but do you guys have any other questions? Do you want to see anything else in particular? Anything related to this week's assignment, last week's assignment?
I'm actually looking at the homework. This is Mercera again. I'm looking at the instructions for the ER assistant example, and I was looking at what I created in the virtual machine environment, and I'm following along with you, and I'm trying. I guess I'm having a little bit of trouble reading what I did in the for the example. I think what I ended up doing is, and hopefully it's correct. So I don't know if you have. Do you happen to have the instructions for the ER assistant example? So you can me. Basically, what it does is it's creating, like, let me see here, 3 different tables and relationships between those tables: the instructor, the student, and then tutoring. And I think the way to read this is that the instructor must teach at least, let me see here, 1 student.
Okay.
And let me see here. And then I'm a little, tell you the truth, I'm a little bit lost from there because there's a connection between, so there's a line from the instructor with the mandatory symbol and then one, and it connects with teaches. And then there's the word takes, and then it connects with student and tutoring. And there's a one and a mandatory symbol in front of like the student table, and then a 0 in front of the tutoring table. But now that that you've explained, I'm kind of not really sure how to read this really.
Okay, so are you talking about this in 21 through? Okay, so you're saying tutoring and instructor. Is that the confusion you have?
Right. I'm just trying to figure out how whether I'm reading this correctly. I see. Yeah.
Yeah. So if you read it right, so a tutor teaches this tutoring. So there looks like there was a potential many-to-many relationship between these two tables, and then that's broken into one-to-many on each side. So what you're saying is each student can take 0 or many tutors. You can take a tutor, you cannot. You don't need to. And each tutor should have at least one student to call himself a tutor, correct? That's how you would read this part of the diagram. To read this part of the diagram, you're saying a tutor can be an instructor, but he needs to have at least 1 year of experience, or he needs to have at least one instructor ID for himself to qualify as a tutor. So he has to be an instructor. And then he can teach or he can tutor 0 or more sessions. You look at the session date here. That tells me he can teach 0 or more sections. He can still be an instructor, but he doesn't have to teach actively.
Wow. Okay. This is awesome. Thank you, Deepa. I was just trying to follow instructions in here, and then I wasn't really, I guess I was just kind of like going through the motions. It didn't really click exactly what I was supposed to be, absorbing from it. But now I see this can tell you a lot about not only the relationships between the different tables, but what important information that's included in each table, so that you can understand the relationships. That's pretty neat.
Cool. So that is why I illustrated with a simple example, when I showed my diagram. It all comes from your requirements document from the business analyst. So we look at the requirement diagram, then the technical person should visualize how it has to be structured in the database. If this diagram is gone, you're done. Your database will be not work as efficient. That's why when you're implementing any software or anything, the first piece is the data architect come on site. They have a lot of questions to ask. Hey, for example, if you're doing a human resources application, hey, how many applicants you will be hiring? How many employees there will be there? What you think will be the growth in your organization? So each row has a size calculation. When you do your database track, I think it's the 4th or the 5th course. So if it's a numeric, then there's how many bits, how many bytes it takes. We calculate that, and that assumes, okay, I'm going to store 100,000 rows in a year of time. So in 3 years, what should be, and you have to allocate that space in the database. You have to project for 3 years. That's why the data architects, they come, they interview, they understand, and then they design the database, and they give the design to the database administrators. Okay, create the student table and assign it 5 gig of space. Create course table and assign it 10 gig of space. And make sure the student and the course table stay closer. So the performance of the database is quicker, faster, efficient. So data architects are paid hell a lot of money. So they come, they understand, they look for various things from their experience, and they design it. And they're normally the first people who come for a software implementation. They work with your infrastructure people, database administrators, business analysts. They do a lot of planning and they set it and then they leave it. They make the basic foundations.
Yes.
Okay. Okay.
So in some ways, this is like the blueprint of your application.
Yes, definitely. Thank you.
Okay. So after you create your entity relationship diagram, you have to convert this into your physical structure in the database. That is what I gave an understanding of SQL types. So there are 3 SQL types, and when you want to convert the diagram into objects, you will be using data definition language. So Deepa will illustrate how you create the table. There is a standard syntax. If you look into the notes, the PDF document, it has the create statements. It's very simple. Once you create one table, copy and paste and change the names for the second. That's how you do it. Then once you execute it, it will go and create the structure. Then you can query your database to see if it is really created in the backend. So first he is creating a table. So she's creating a table called new with ID, first name, last name. You're creating the primary key also, Deepa?
Yeah.
Okay. So the syntax what she's typing is create table, table name is the syntax. So create table and table name is new with columns ID, it's an integer meaning number, and the ID is a primary key. First name which a varchar and she has given the length, and last name is a varchar and the length. So that is the syntax. So once you put a close parenthesis and a semicolon, some editors require a semicolon, some do not. You can try this, and then if you hit the select it and run, it creates the table.
And sometimes I already know this is not going to work because of this red X here. So I know I have to expect some error. So I'm going to run it and see what error it gives me. Okay, so it's not happy with my SQL, my syntax.
You want to give it some size there, varchar? Just put a size. Okay, that's the okay.
That's the thing. It was expecting a size for the field. Okay, so now I said first name, last name, and so now it's all happy with me. So now it created the table, so I can refresh. There's my test database. There's student table, and it's an empty table. So if I do a select star, all I'll get is blank. And now I can write the insert statement to insert into this table. I guess you guys have already done that this week. You've all your assignments had this create table and insert statements. Anything else you guys would like to see?
Deepa, can you show what are all the tools on the virtual desktop?
Okay, so we've already talked about the MySQL Workbench. So the first 6 weeks, this will be your tool to run SQL queries, create SQL queries. This is ER Assistant. That's where you'll draw your ER diagrams. And I believe for Tableau's or the shortcut is already installed on your desktop here. And I don't know what else.
And R.
Oh, okay. Python.
Python.
The license.
All right,
Yeah.
Python.
Okay, so this is R Studio. This is where you'll write your Python scripts, I believe.
Okay, so these are the tools. If you want to install on your desktop, then you have to go get them installed. If you get the errors, it's very difficult for us to figure out. We will try the best we could, but it's always advisable to use the virtual desktop and go do your work and then upload your work from here to your class directly by opening an Internet Explorer. That's the best and easy way of getting your homework done.
And for guys that had confusion taking screenshots, it's advisable that you just finish your work here and use your local and just use the snipping tool here or Snagit or any other tool. Just take your screenshot outside the virtual machine, because if you try to use the snipping tool or any other screen capture software, it's known to bring down the virtual machine. So please use your local to capture the screenshots, and then you can pass it on to your Word docs as needed. I know there were a lot of questions that came out of how do I get this to work. That's a little workaround for this semester.
Any other questions? Clarity? We can help you. It's almost we have reached the end of the hour. We can have a follow-up session for normalization. It's a very advanced topic. We will see if we need to cover it. If we need to, we will have a follow-up session. I don't want to start now and it will all be off track. It's pretty complex. We have to start at the top of the hour so that we could go on.
I thought I saw Brian. Brian, was that you? Did you have a question?
Yeah, just on your screen there, you've got a tab on the center left. I never saw that when I was...
Yeah, it's possible you may be using the Horizon client instead of the web-based client.
I was, yes.
Yeah, so this is only specific to the web-based client, and this area allows you to copy-paste text into and out of this client.
Okay, because I was going to say, yeah, I did not have any problems copying and pasting without that tab. So
okay, yeah, if you had the Horizon client, you're good.
Okay.
Okay. If there are no questions, we will call it a day. But overall, do you guys like the format? Do you like the illustration what we are doing? And we have also recorded some videos and made it available for the students. And we'll also record this and give it as well.
If you have any feedback, please do share with us so we can improve for upcoming sessions.
So there will be a couple of 2 or 3 more sessions. We'll have a session for W, and if needed, if we think people are not understanding the table concepts, we will definitely have a normalization webcast. It's a very critical, very complex. So I'll simplify it and make sure you all understand. Okay? Okay. So if there are no other questions, I'll stop the recording.